Welcome back. This is video 10 of making schematics and PCBs with KiCad using KiCad 6 and SMD boards. In this video, I'll show you how to finish your schematic capture, add and arrange symbols and connect them with wires, add symbol designators, values, and footprints, and prepare everything for exporting to the PCB editor. From my original schematic that I need a capacitor, a transistor, a speaker, a battery connection, and a couple of probe wires. So let's add those symbols on KiCad's schematic editor. First, a capacitor. So I'll go to Add Symbol. In the filter box, I'll type in capacitor. These are regulators. If I go down to just devices, I have symbols for capacitors. The symbol that I want is an unpolarized capacitor. So I can double click on it. I'll put it right there. The next symbol, there was a transistor, so I'll click somewhere else, type transistor, and it was a 3904. So there's a 3904 symbol. I'll double click on that and add that. So if I type in a speaker, there's my symbol for that. And I needed a battery. I can do a single cell battery or a multi-cell battery. And then I need some probe wires. If I type in probe, here's a symbol for a test point probe. So rather than the test probe symbol, if I type in test point or test, here's a symbol for a test point. So I'll click on that. On the original schematic they were turned, so I'm going to hit the R key and rotate them, then highlight this one and do Control C to copy, Control V for paste, and now I have my two test points. Before I connect the wires, I'm going to move some of these components. So I've highlighted both of those at the same time, and then I can drag them. Another way to move symbols is just hover over it and hit the key M on the computer. That's a hotkey for move. So I can move these symbols to anywhere on the board I want and then click to release them. So now that I've moved components around and got them where I want them, I will start connecting the wires. So let's go over to the right side and it says add a wire. So I'll click on that. I'm going to go from my positive of the battery, click once, get up to the test point, click again. Then I'm going to go from the other test point, click again to link to R1, then click again, and link to R4. Notice it's just slightly off. So I can drag it down and click to R4. Looking at the schematic, I see that pin 4 and pin 8 need to be connected to that line. So I will draw pin 8 with a connection, and then pin 4 I'll draw a line coming out and then up to that rail. Now my schematic shows that after R4 it connects to the speaker, then to the collector of this 3904 transistor. So I'm going to draw a wire from R4 to the speaker, then from the speaker to the collector of that transistor. Then see how the transistor is connected to R3, and then R3 is connected to pin 3 of the IC. Now if I double check, I should have from my IC pins 1, 2, 3, 4, 6, 7, and 8 connected. Pin 5 shows no connection. So here in my KiCad schematic I've got pins 1, 2, 3, 4, 6, 7, and 8 all connected. Pin 5 is showing no connection. There's a special symbol for that in KiCad. I'm going to go over here to the right side to the Add No Connection flag and put that right there on pin 5. And what that does, I don't think it's a good idea to leave floating pins, which means pins not connected on an IC, but since our original schematic had that and I breadboarded it, it worked fine. Normally you would tie unused pins to ground so that they know that there's a certain reference voltage on those pins. Otherwise sometimes you get weird issues happening. But for now, I'm going to leave that as a no connection to demonstrate how you would use a no connection flag. Alright, I think we've got all the connections correct. It's just the wires are kind of jumbled around, so if we wanted to move our components around and then redo the wires, it might clean up the look a little bit. So let's do that. So here's our final schematic. Our next step is to label all the symbols with the right numbers. KiCad needs to know that each symbol has its own unique number identifier, so it's not doubling up. We could double click on each component and then change the reference number to whatever it needs to be, or we could go up and use this fill in schematic symbol reference designators, and this will try to do all of it at the same time. We can specify the entire schematic and then keep existing annotations since we've already got the resistors numbered. So let's go ahead and hit annotate, and it leaves us messages of everything that it changed. So we can close, and now if you look at it, capacitor 1, battery 1, transistor 1, speaker 1, they're all labeled. But the values are not listed, and we can fill those in from our original schematic. So we can double click on C1, change the value to 0.01 microfarads. Designate the battery as 9 volts. Okay, now we have our values listed. The next thing we want to do is make sure that all the wires are connected where they need to be. The next thing in our workflow is an electrical rules check. So we'll click on that, run our ERC, and we end up with a couple of errors. It says the input power pin is not driven by any output power pins. If we close that, these arrows indicate which pins are the problem. KiCad needs to know where power is coming from and where it's going to in order for this schematic to work correctly. So we can't just say, hey, just trust me. But it has a special designator, a power port. So if I click on the add a power port, I'm going to tell it I need a power flag. Power flag symbol, I can attach it to pin 8. I'm going to rotate that so it's kind of out of the way and put it right there. Then I'll do the same for pin 1. Another power flag attached to pin 1. Now I can run my electrical rules check again, and everything's cleared up. Okay, I know where power is coming from, where it's going to. So I've passed my electrical rules check. And then the next step in my workflow is I can use this Run Footprint Assignment tool. So if I click on that Run Footprint Assignment tool, after it loads the libraries, it has a list of all of the footprints that have already been assigned in my schematic. And it lists what I don't have. So I can go up here to the Filter Footprints and just search for, if I click first on, say, I want to search for a capacitor. And I can filter footprints by the library. So it comes up with capacitors. These are surface mount device capacitors, that's good. As I scroll down through the list, I'm trying to look for what looks familiar. I notice there's a 1206 3216 metric. That's the same footprint assignment as the resistors I had. I might as well go with that same one. Double click on that, it assigns that footprint to that capacitor. Next we want to add the battery footprint. So I'm going to click here, and then over here in the footprint libraries I can click on battery. You can also search for it in footprint filters if you want. Comes up with the filtered footprints either way. If you're not sure what to get, let me show you one way you can narrow down your choices. If you right click on one, choose View Selected Footprint, and it comes up and shows you what it would look like. There's also a Show 3D Viewer window, but that's not the battery we wanted. Again, right click on a different, or click on it, then right click. This is not a 9-volt battery connector that I want. When I click on this one, I can right click, View Selected Footprint, and this one looks like a 9-volt battery, but I'm not sure if this is a 9-volt battery connector. One way to tell for sure, look down here at, has keywords, 9-volt battery holder. Right? Also, right here in the filtered library description, gives a data sheet for it and has the keywords 9-volt battery holder. So this is the battery holder I want to select, so I'm going to double click on that and fill in the battery. Next I need to do the speaker. If I go to Mauser's website, I've found a speaker, a surface mount piezo buzzer speaker. It's got this part number, CMT8504. So when I go to my footprint library, I can click on that and search for a buzzer or beeper speaker. Here's a list. Scroll down through the list until I see one there's an 8504. That's what I want. I'll double click on that and put that in as my speaker footprint. When I reload my Run Footprint Assignment tool, it comes up with that speaker footprint. Now I need a test point, which is really just a pad I need on the board. For my test point pad, I will scroll down on the footprint libraries to test point. Click on that. Here's all my possible footprints. If I scroll down, I can see different pads. Since this is going to be a surface mount, I just need to solder to the pad. I can pick maybe a 2 by 2 millimeter pad. Again, if you want to right click and view selected footprint, that's what it looks like. So I'll go ahead and double click on that and do the same for the test point 2. Now all of my footprints are assigned, and now I'm ready to generate my PCB layout. Thank you for watching this video. Now your schematic is ready to export to the PCB editor. Next, watch video 11 of making schematics and PCBs with KiCad, and I'll explain the details of exporting your schematic to PCB editor and finishing up all of the PCB layout and preparing it to print. We'll see you next time.